In the geometry step, as we saw, we were affecting the mathematical model. We were specifying geometric parameters that appear in the mathematical model. Now we're going to move on to meshing, where we are not going to affect the mathematical model. We are going to affect how ANSYS is going to solve that mathematical model. That is, we're affecting the numerical solution. Go to the project page and double click on model to bring up the mesher. This brings up what's called ANSYS Mechanical, and it's our interface to the solver that does all the calculations of, derives the algebraic equations and so on from the mathematical model. And this is showing me an isometric view. So let me click along Z to see the view that we have been considering in the pre-analysis. If your view gets garbled, you can always click on Z to get back this view. I'll highlight mesh in the tree and click on update, and that'll give me the default mesh. I always like to throw a default mesh to see what I get. And I'm getting more nodes than I want. If you remember in pre-analysis, we considered the case where we have 3 nodes, and that's a case I want to do first. And so let's decrease the number of nodes. By the way, you might get a view. So if I go to view, pick shells and beams, okay, you might get a view that looks like that. That's because it's it's taking each element, right, and it's putting the cross section on it. Purely visualization thing. And to make it less confusing, I'll just keep that turned off and click along Z. And then I'll go to mesh and I'll say mesh control, sizing, and I need to specify a size for the elements along that line. So I'll select the line selection filter or edge selection filter, click on that and say apply. Okay, so this sizing applies to this entity, and I will say number of divisions is 2, which is equal to the number of elements. And behavior I will set to hard. I talked about this in other examples, like I believe in conduction, and this is a hard setting, so I don't want ANSYS to mess with it. For simple geometries, you give it a hard setting for the element sizes and so on. For complex geometries, you give it a soft setting because you want to give ANSYS enough flexibility to try to fit complex parts. Okay, and then I'll say update. And if I highlight mesh, it looks like it has 3 nodes, which is what I want. However, if I go to statistics, it shows me 5 nodes, and that's because it's putting in these midside nodes. So if I go back here and select that, so it's putting a node in the middle, and the node in the middle, it seems like it at least. And in the conduction example, our conduction case study, I talked about how the midside nodes, or even in the big ideas in finite elements, how the midside nodes gives you a higher order interpolation. Here we already have a third order interpolation, a third order polynomial, so we don't need that. And so I tried dropping the midside nodes. By the way, in an earlier versions of ANSYS, this is I believe under advanced. So you might see it in different places. This is new, that it's over here in 17.1. So if I drop it and then I update the mesh, it didn't change it. Okay. However, it turns out it's not putting in the midside nodes, and one can confirm it once we do the solution. And if I remember it, I will show you how to confirm it. Okay. So the number of elements is 2. The number of nodes is 3. And this is node 1. We can consider this node 1, node 2, and node 3. That's all we really need to specify in the mesh. So here the meshing is very simple. But before we go on to completing the specification of the mathematical model, I want to consider the number of degrees, what's called the total number of degrees of freedom. We'll take a look at that next.